100 lecture podcast series. I'm your instructor, Brian Krause, and today we're going to begin Chapter 5, Part 2, which introduces El Nino and La Nina and their global effects. In this mini lecture, like all mini lectures, I'm not going to cover all topics or ideas presented in your text. Rather, my aim is to highlight a few key ideas and discuss them in a bit more detail. In this lecture podcast, I've included concept checks in the form of non-graded quizzes at the end. When you get to the quiz slide, right-click the mouse and select Pause, which will pause the narrated PowerPoint. This will allow you time to answer the question. Once you've answered the question, right-click the mouse and select Resume, which will restart the PowerPoint. The following slide will provide the correct answer and an explanation. If you're watching this as a video, you don't need to right-click the mouse. Simply use the controls at the bottom of the video to navigate. On that note, let's get to the material. So the learning objectives here is just kind of discuss how El Nino and La Nina conditions form and what their effects are. So one of the basic tenets of physical geography is this interrelatedness of the various elements of the environment. And nowhere in the environment is this interrelatedness shown better than at the air-ocean interface. And there are two great fluid systems are interacting in this intricate and often kind of perplexing fashion, so that the cause and effect becomes almost meaningless concepts because they're so intertwined. So an excellent example of this interrelatedness is the complexity of something called El Nino. It's an episodic atmosphere and ocean phenomena of the equatorial Pacific Ocean, and it's particularly prominent along the west coast of South America. And so shown in this figure, we can see an El Nino occurring by this warm ocean surface temperature, which is illustrated in red, off the west coast of South America. So El Nino translated from Spanish as the boy child, and the Peruvian fishermen originally used the term as a reference to the Christ child to describe the appearance around Christmas time of this warm ocean current off the South American coast. And as we'll see, when this warm ocean water came in, it really killed off the fishery industry there. So it had some kind of devastating effects as well for local fishermen. So to begin our conversation about El Nino, it's kind of important to look at, well, what's it look like when there's not an El Nino event going on? And that's shown here in this figure, where we can see that the trade winds blow towards the west across the tropical Pacific Ocean. And these winds pile up warm surface water in the West Pacific, so the sea surface is actually about 2 feet higher in Indonesia than it is at Ecuador. And the sea surface temperature is about 46 degrees Fahrenheit higher in the west, with the cool temperatures off of South America due to this kind of upwelling of cold water from deep down in the ocean. And this cold water is really rich in nutrients, and it supports a diverse marine ecosystem and major fisheries, as I mentioned in the previous slide. And we will find too that the rain is found in the rising air over the warmest waters of the West Pacific, and the East Pacific is relatively dry. And the diagram shows this typical convection loop with rising air over the West Pacific and this sinking air over the eastern. So now looking at El Nino, when an El Nino is occurring, shown here in this figure, the trade winds either relax or cease, and in the central and west Pacific, it leads to a movement to the east of this warm pool of water. This warm pool of water moves eastward until it spreads across the entire Pacific Ocean. And the normal cool water located off the South American coast is replaced by much warmer waters. And without the trade winds, this upwelling, which supplies the cool subsurface ocean water, is now weakened. And this leads to the warm sea surface temperatures that are shown in the figure at the top of this page here, with the strongest deviations from the normal just off the South American coast. Rainfall follows the warm water westwards as well, with associated flooding in Peru and droughts in the normally wet regions of Indonesia and Australia. This eastward displacement of the atmospheric heat source overlaying the warmest water results in a large change in the global atmospheric circulation pattern, as you can see in this diagram. And this change in the circulation pattern in turn forces change in weather in regions far removed from the tropical Pacific, such as Arizona. El Nino episodes tend to occur every 3 to 5 years and usually last 9 to 12 months. So in general, El Nino results in an increased precipitation across California and the southern tier of states, and decreases precipitation in the Pacific Northwest and in the Ohio and Tennessee valleys. A milder than normal winter across the northern states and western Canada is also a common effect. So in the eastern United States, El Nino episodes favor more coastal storms at the expense of a fast eastward tracking storm across the northern states in winter and early spring. And due to the warm season, El Nino influences hurricane developments, resulting in more eastern Pacific hurricanes and fewer Atlantic hurricanes. So we just got done talking about El Nino. Now let's take a look at La Nina. So during La Nina years, kind of shown here in the figure at the bottom, the trade winds are unusually strong due to this enhanced pressure gradient between the eastern and western Pacific. So as a result, upwelling is enhanced along the coast of South America, contributing to colder than normal surface water temperatures over the eastern tropical Pacific and warmer than normal surface water in the western tropical Pacific. El Nino may last anywhere from 1 to 3 years, and El Nino and La Nina tend to alternate in this irregular cycle, which is often referred to as the El Nino Southern Oscillation. So in these two maps, we can see how El Nino affects precipitation and temperature patterns across the U.S. And this is for the El Nino of 2009, early 2009. And I would like you to do a little research, and by research I mean Google key terms, to explain what causes these El Nino precipitation and temperature patterns. And I'll give you a hint that this process begins over the ocean and then later affects other systems that we have discussed in part 1 of chapter 5. Also, I'd like you to do a little research on how El Nino affects hurricanes in the Pacific and Atlantic Ocean. For example, are there more hurricanes, less hurricanes, and why? And for this research, you don't need to submit your findings, but these questions could appear on chapter 5 quiz. So I'll let you kind of explore these maps on the global effects of El Nino and La Nina. I don't expect you to know this for the quiz, but more as a general understanding of the impacts of this phenomena, that this El Nino has a global, and La Nina has a global effect. It's not just a localized thing occurring along kind of the equator, but it's far-reaching. So take a look at that. And that concludes this PowerPoint slide presentation for Chapter 5, Part 2. The following slides are just a couple of these chapter review questions for you. See you in the next lecture.